Okay, next we will discuss a serial connection of the resistors. Serial connection refers to the connections between components without bifurcation. For instance, this subcircuit is composed of n resistors in series. If we want to transform it into a resistor equivalently, these two subcircuits need to have the same UI form and parameters. It must be U equals Req times I, but for it, we need to write it as U equals watt times I. Then we write out this watt. First, because it's a serial connection, we can use KVL, that is, U equals U1 plus UM. Then each UK is equal to RK times IK based on Ohm's law. We substitute them all into it. We know that it is equal to R1 times I1 and plus Rn times In. Based on KCL, I1 equals In equals I. So it is equal to R1 plus R2 plus Rn, then times I. Look, isn't it the form of U is equal to watt times I? Comparing the two equations, we can find that Req equals R1 plus Rn. After discussing the equivalent resistor of n resistors, let's talk about the very important voltage divider. As just discussed, we know that for this circuit, Req equals R1 plus Rn. Now we discuss that for any resistor, such as a resistor K, what is the proportion between its voltage and the total voltage? It must be Rk times Ik over Req times I. Because Ik and I are the same, so it equals Rk over Req. Certainly, we can infer that the voltage of the resistor K equals Rk over Req times U. What does that mean? For a serial connection circuit, the larger resistor has larger voltage. This conclusion is very important. Then we give a concrete example. This example is a voltage divider with two resistors. You are suggested to remember the conclusion. Please note that we have special considerations on the reference directions of the voltage across these two resistors. The first resistor is upper positive and the lower negative, which is consistent with the port voltage outside. The second resistor is opposite to the first one, lower positive and upper negative. Applying the equation and the reference directions, we have U1 equals R1 over R1 plus R2 times U. And U2 is equal to minus, which is very important, R2 over R1 plus R2 times U. This conclusion is easy to remember that the voltage divided by one resistor is equal to its own value divided by the total resistance and multiplied by the total outside. Then we discuss a practical application of the voltage divider with two resistors, such as a real voltage signal source like this. It can be expressed as a form of signal voltage source and internal resistor. The source supplies directly to the load, and this load is expressed as a form of a resistor. According to our previous discussion on the formula of voltage divider with two resistors, we know that the voltage of the load is equal to RL divided by the sum of RL and RS and times U. So larger the resistance of load gains, the larger load voltage, which is obvious. Based on a similar consideration, how large should the internal source resistance be so that the load voltage obtain higher value? Right. The smaller the internal resistance of the source is, the larger the voltage of the load is. This is a very important discussion on load obtaining the maximum signal in case of voltage signal sources.